I heard that you got the important point. You can ask the important questions.
We'll start today's topic as discontinuity and its types. Shall we start our class?
Sir, voice.
Then the left hand limit and right hand limit at that point is equal to the value of function at that point. The strict condition for function f of x to be continuous at x equals to a is limit x going to a minus f of x equals to limit x going to a plus f of x equals to f. We know this is the strict condition for function f of x to be continuous at x equal to a. Left hand limit equals to right hand limit equals to value of function. If at least one of these three values differ from others, or at least one of them does not exist, we have discontinuity. So if one of them differ from others, let's suppose left hand limit is not equal to right hand limit, or
Separate important questions.
one of them does not exist, left hand limit or right hand limit does not exist, then we will say we have discontinuity. So f of
The
x
second question is that law of conservation of energy
is said
for body. And third
to
question
be
is that potential and kinetic energy of the spring.
discontinuous
Fourth question
at
is
x equals to a. If
and
first
between the two ones. So yeah, this is elastic collision in two dimensions.
limit x tends to a minus
And they
f
are
of x and limit x tends to a plus f of x exists but are not equal.
Sir,
Second, limit x tends to a plus f of x and limit x tends to a minus f of x exists and are equal.
important questions.
But
sir,
not equal to
Yeah, sure.
f of a.
sir,
So I have some
Third,
sheet
f of a is not defined.
sir, sir,
Uh,
voice,
happen.
is this one.
background,
And if you have any doubts,
voice.
please send the solutions.
Voice is not clear.
Yes, sir. Background voice.
Okay. So if we have these three conditions and we have one more, at least one of the limits does not exist. Fourth,
Yeah, actually, no, I didn't share
one
the screen.
of
I'm checking the solutions.
the limits does not exist. If we have these four conditions, we call it a discontinuity. First condition is if limit left hand limit is this x going to a minus f of x, and this is right hand limit x going to a plus f of x exists. These both exist but are not equal. That means left hand limit is not equal to right hand limit. So we have discontinuity. If limit does not exist, we cannot say function is continuous. We cannot go for continuity. Second, if right hand limit and left hand limit they both exist and are equal but not equal to f of a, value of the function at that point a. So we have again discontinuity. Third is f of a is not defined. The value of function at point a is not defined. So we will say we have discontinuity here also. And fourth is at least one of the limits does not exist. If
The screen is visible.
either f of limit LHL does not exist or RHL, right hand limit does not exist, then we say function is discontinuous.
Work energy. Okay. So we'll discuss the work energy questions right now. I request you in the next class also please share your questions.
Now we have types of discontinuities. Types of discontinuity. One is removable. Second is non-removable. Removable, non-removable. In removable, we have two types. One is missing point. Isolated.
Okay. So let's start the class.
Non-removable
The
is
first class they are asked that work for.
Sir,
finite type.
sir,
Hmm.
when you will take that matrices class of linear equation?
I will take some time.
Work energy.
Okay.
Infinite type,
So hope you already studied work energy theorem.
and
So
we
just
have third
revising the
here
concept only.
oscillatory. In removable
So let's
discontinuity, we have missing
the
point
mass of the body.
discontinuity and
This is
isolated
the
point.
mass of the body. And
Missing point means at that point
the
our function is not defined.
Sir, disturbance is coming background.
and I just applying the
Actually,
force
physics sir has also class.
and I'm just pushing the force. So I'm just pushing the object here. That's why it will displace the second. So we already know the displacement is we are representing capital S. So here we have to find the
We have removable discontinuity. If we can remove the discontinuity and make this function continuous at this
yes
point
or no?
A, then we call it as
Your
removable
voice is not audible.
discontinuity. In case of removable
Oh, sorry. Okay. Now is my voice is audible.
continuity,
Yes, let's see what can I
the
do here.
limit
I just taking a body. I am just giving a push,
of
and the
the
body is displaced from this position to and this position. How much displacement is it? It is more
function
the distance. Yes. Here we are using the work energy theorem. We wanted to find the relation between the work and the energy. So let's take work.
limit
What is
x
the
going
work
to
done?
a f of
We
x
already know
necessarily
work done is
exists.
equals to force into displacement.
But
Here I am taking infinitesimal small. That's why
it is
this W can be written as a dW is equal to force
either
into ds. Because F is a constant here. So I
not
have to
equal
substitute F. What
to
is
the
this
value
F? Mass into acceleration into ds. I can write my A in terms of
of the function
dV by dt to ds. But
at a, that is f of a, or f of a is not defined. We have, in case of removable discontinuity, the limit of the function x going to a f of x necessarily exists. That means left hand limit and right hand limit both exist, but it is either not equal to the value of function at a. That means limit is not equal to the value of function f of a, or f of a is not defined at point a. However, it is possible to redefine the function in
no. Actually,
such a way
I am not talking. There is a math class is also happening actually. I'm not talking. Is my voice
that
is
the
audible?
limit
Okay. See. Now up to here you understand right this point.
equals the value
Variable is equals to mass into acceleration into displacement, right?
of the function
Okay. So let's dW is equals to
at
mass
that
into
particular
and dV, and
point.
I just replace this dt to d. Okay. So actually we can replace this dt
So
because
if
both are the derivation.
f of a
Right?
is not
If
equal
this
to the
is the
limit
case,
of
I cannot do it like this.
function
Because
at
this
that
is
point,
also
or f
ds,
of a is
that is
not
small. So
defined
that's why I
at
replace it from
a.
so we know ds
So we
is
have this
nothing but
possibility to redefine the function in such a way that the limit equals to the value of the function at that particular
dW
point.
equals I take integration and both sides.
That
Mass
is
is a constant, it will come outside and v.
limit x going to a,
So here we have to take the
f of
limits.
x
What
equals
are
to
the
f
limits
of a.
here?
We can
I have
define
the
it like
initial
this
velocity
at that particular point.
the mass one
Removable discontinuity can be further divided into two types, which one is missing point discontinuity and one is isolated point discontinuity. What do we mean by missing point?
m into a square by so upper limit minus lower limit. So that's why equals to m
Missing
into
point discontinuity.
upper limit minus lower limit.
The discontinuity
So what is this? This is nothing but W. W is equal
is
to
said to be
so W is equal to this is kinetic energy of the
missing
final kinetic energy of the cage. So
point type
work done is nothing but kinetic energy.
if
So what we have to remember
if
here,
the limit
we have to remember just we have to substitute the work formula
of the function
and we have to write the A in terms of the derivation.
exists.
Second point is and this T is interchanged to the Ds. That's these 3 points we have to admit. Then you
At
will get
point
the work energy.
A, but
So next question.
the
What is the next
function
question?
is
Son
not
of what is the next question? Free
defined
fall body, right? Yes.
at that point.
Yes. Next question, free fall body.
That limit x going to a, f of x exists,
So free
but
fall
f
body.
of a
So usually this is my
is not
surface.
defined. The discontinuity is said to be of missing point type if the limit of the function exists. The limit at this point exists, suppose at point A, but the function is not defined at that point.
Position A and at the position B,
F of x limit exists, but f of x is not defined.
How to find that my potential energy, kinetic energy, and my total energy at this each position. What I have to find? I have to find the potential energy, my kinetic energy, my mechanical energy, nothing but total energy. What is the total energy? That potential energy plus kinetic energy. Okay. So at this position, at point A, the potential energy is maximum. Okay. And here kinetic energy is going to be 0. At this position, the potential energy
See, consider
equals to kinetic energy.
a function
Point C, what is going to be potential energy
x square minus 1 divided by x minus 1,
maximum. These 3 points.
where x is not equal to 1.
So let's solve the question each.
F of x equals to x plus 1. How? This can be written as x minus 1 into x plus 1 divided by x minus 1. Since x is not equal to 1,
So
I can
let's
cancel these two, then it will become x plus 1.
Position A.
What will be the graph of this function?
Position A. So
This
what
will
you
be
have
the
to find?
graph
You have
of
to find the
function.
total energy. What is the
At
total
x equal to 1,
potential energy?
it will
plus
be
kinetic.
not
So we have
defined.
to find the potential energy.
Here we have this point which is missing, 1.
This is the height h. Okay. The height h. That's why my potential energy.
Now, if I redefine this function, f of x, x square minus 1 divided by x minus 1, x not equal to 1, and 2, x equals to 1. If I redefine this function, x equal to 2 at x, f of x equal to 2 at x equal to 1, then
Is there any disturbance? No, right?
Sir,
so this
Thank you. Okay, let's
this
say.
function will be
So what is the
now
total energy? Total energy or mechanical energy is equal to
continuous.
potential energy plus kinetic energy. What is the potential energy? mgh plus 0. That's why total energy at position A is equal to
sir,
Hmm.
now we have to find the
not an
at position B. So position
See, I had this function x square minus 1, x plus
at position
x
B,
minus 1.
let's say I have to find the again total energy.
So
equals to
it is
potential
x plus
energy
1.
plus kinetic energy. And what is my potential
At 1
energy?
it will be 0. Let's say this is 1.
Potential energy is equal
This
to
was the
mgh. So, but this is my point B.
graph.
Okay. From this, I have to take this height. So, usually consider so my ball from position A to position B, it is placed at X. So, B to C ఏమైపోతుంది height total h minus xi. కాబట్టి in the place of h, what I have to substitute? I have to substitute mg times h. So mgh minus mgx. This is the potential. Now what we have to find? We have
So
to
at
find
this
the
point,
kinetic.
1,
What is the kinetic energy?
this is
Kinetic
point
energy
2.
Google
Sorry,
So
not
kinetic energy
testable. What?
can you hear me?
of m v square. So
What
if you
are you
see
telling,
here,
sir?
the potential energy
Sir,
is came in terms of the height and x.
Sorry,
But here kinetic energy came in terms of the
please
velocity.
start, sir.
So we have to convert this velocity in terms of height.
I cannot hear you.
H naught is how we can use. We have to use the kinematic equation.
Please start, sir.
Kinematic equation. Which kinematic equation I have to use? V square minus v square is equal to
If we redefine this function at
initial
like
velocity
this,
zero. That's why v
f
square
of x equals to
2
x square minus 1, x minus 1,
What is this means?
x not equal to 1, and
How much distance
2
from A to
at
B?
x equal to 1.
X
Now,
distance.
the
X
graph
plus
will
A
be
plus
this now.
X plus.
and at this point 1
in B
f of
square,
a
I have to
is
substitute
2, so
2ax.
this is now continuous function.
So my kinetic energy
Since
of m
we are
ax. Okay.
able
A
to
will
remove
cancel. Body is falling or free falling. That's why A become axis.
continuity at x equal to 1
So now find the total energy. Total energy is
by
potential energy.
redefining
What is the potential energy?
the function
This is the mgh
f of x.
plus mdx.
We
Both are
say
will cancel. Total energy is
that
equals
f of
to
x
mg.
is
At what point? At position. ఇక్కడ పొజిషన్ A
removable
దగ్గర ఎంత వచ్చింది? mgh. పొజిషన్ B దగ్గర ఎంత వచ్చింది?
type of
mgh. Let's find the
discontinuity
positions
at x equal to 1. Is this clear? This type of discontinuity, removable type of discontinuity.
at position C. What we have to find position C? The total energy is that P position. We have to find the total energy plus total energy, potential energy plus kinetic energy. So, in case what is my potential energy is going to be? My potential energy at point C.
In this case, we had one point which was missing.
Kinetic energy is going to be
At that point, function was not defined. We redefined our function and
so 2as s అంటే ఏంటి the displaced from A to C. A to C ball displace అయింది. హైట్ ఎంత మొత్తం h. That's why 2ah. Kinetic energy is equal to 2ah. So what is the total energy? Total energy is equal to potential energy plus kinetic energy. Potential energy is 0. Kinetic energy is equals to kinetic energy is one mgh. You have to substitute mg.
hi ma'am.
So half m have to substitute this one, which is equals to
Hello ma'am.
g x plus n we have to give a to g. We have to put h. So kinetic
Yes,
energy
sir.
is
Yes,
become
sir.
mg. Now potential energy is 0, kinetic energy is mgh. The total energy is going to be
Sir,
point is
why-
mgh. So
Second
this
is
observe
isolated
total
point
energy is
discontinuity.
you observe carefully. So free fall body free fall అయినప్పుడు the total energy is nothing but potential. ఇప్పుడు ఏ పాయింట్ దగ్గర ఈ పాయింట్ దగ్గర కనుక్కోవాలన్నా
Isolated point means, let's suppose we have a function defined on some interval or some if
Yes, sir.
yes
potential energy of the object.
Sir, this ऋषभ सर का वॉइस थोड़ा डिस्टर्ब हो रहा है बच्चे के लिए.
Is this good?
Not Rishab,
Krishna sir
Krishna sir, ma'am.
is
Rishabh,
taking a physics
Krishna
class.
sir is taking the class because I understand completely from your end, but kids are not able to understand. They are informing me. Is anything alternate way you can find out?
We are in same room.
Hello. Hello.
Is this clear? Andy? For everyone?
Yes, sir.
Is it clear?
We are in same room right now.
Yeah, you're
Actually-
staying home. Krishna sir बात मेरे को सुन रहा है.
Adhishi and Samina? Yeah, okay. So, next question. So,
Sir, explain this topic, sir.
that is the collision in, yes, collision in two dimensions. That one, collision in two. Right? This one, right? The second question is given. No. The third question is there given this one. So finding potential energy and kinetic energy per spring. Right? So yeah. So let's take the spring. Initially, I'm taking the spring. Okay. So I just attach a body to my spring. This is my attachment to my spring. Okay. So there is no pushing or pulling on the body. So that's why my spring usually it is located at this point. X is equals to 0. 1 minute.
Okay, shall we continue? Isolated point discontinuity. In this type of discontinuity, the limit
Sir, once explain before topic, sir.
of the previous slide.
Uh, yes, yes.
In previous slide, we had missing point
No,
discontinuity.
sir.
This point was missed in our domain. We redefined our function at this
Yes.
point to be
Sir,
the limit. Yes.
explain from starting, sir. Types of discontinuity.
Ah,
Yes.
okay, let's come back to the lecture. In this type of discontinuity, the limit
Sir,
of the function exists
sir.
at the
No, yeah, yeah. Wait.
particular point, say at x equal to a, and also function is defined at that point.
Sir, sir.
That modes are not equal. That is
Now see here.
Sir,
limit x going to a f
I
of
just put
x
the opposite force. This is called external force.
exists,
I put the object. So ఏమైపోయింది? Actually,
but
initially
limit
my
x
body is
going to
getting.
a
So it is displaced
f
at a
of x
distance small
not
x
equal to f of a.
distance. So మనం ఇటు సైడ్ పుల్ చేసినప్పుడు స్ప్రింగ్ లో there is a force will act on the spring that is opposite to the displacement of the body. In the third case, if I take the third case, okay, so this is the third case.
sir.
Yes.
The third case,
Explain from beginning, sir. Not understand.
push the object with force. Which force it is the external.
Why? What happened?
Voice disturbance is coming from your side, sir.
Usually it should be the at x is equal to 2. Okay, so when I push it, it is displaced at
Sir,
Okay.
and there is a force in the
From
spring
here you can
that act on the applied external. This is called spring.
hey, Bhagya, video.
Understand this concept,
sorry.
right?
Explain from starting, sir. Not understand.
Okay, what will happen right now? The force, which force, spring force is directly proportional to the minus x. So
Physics are teaching us class 16, sir.
this right side, left side, అయితే constant, I will get k minus of x. How we can write this is minus kx. Okay. Now let's take the force. What is the let's take the work done. What is the work done? Work done is equals to force into displacement. And just we are taking the displacement infinitesimal small. That's why I have to take the d double is equal to force into p. Okay, what is this force? This is the spring force. You are finding the spring force. In the place of F of S, I have to substitute this Kx, right? Which is equal to minus Kx into dx. So what I have to do? Now I have to do the integration. Do integration. K is constant, so that's why I brought the K outside x into dx. This is the dx. So integration, this is going to be W minus K x squared by 2. Okay. So we know what we know. Work done is equal to negative of the potential. That's why work place on the negative of potential energy, right?